Absolutely. This is a great place to go deeper. Fire pumps are mission critical, and special power supply isn't just a buzzword. It drives real design decisions that inspectors care about. I'll break this down practically, then flag CEC versus NEC differences, since that's where people often get tripped up. What special power supply really means. In practice, special power supply means the fire pump must keep running, even when everything else in the building is failing. So the supply must be reliable, independent, protected from common failures, and not easily interrupted. This is why fire pumps are treated differently than almost any other load. Acceptable power supply arrangements. Typically, you'll see one of these three. A normal utility supply, dedicated. Separate service or dedicated feeder, taken ahead of main building disconnects with no unnecessary overcurrent devices and no load shedding allowed. This is the minimum setup if no backup source is required. B normal plus emergency, generator. Very common in high-rise buildings. Requirements in practice. Automatic transfer to a generator size to start and carry the fire pump. The fire pump cannot be load shed and the transfer must occur automatically. The fire pump ATS is not allowed to be downstream of general emergency ATS logic. C. Dual utility feeds. Two independent utility sources with physically separated routes and automatic transfer, often required where generator reliability is questionable or utilities mandate redundancy. Feeder routing and protection. This is where projects fail inspections. Fire pump feeders must be as short and direct as practicable, routed away from other building loads and high-risk fire areas, and installed in concrete, a fire-rated shaft, or fire-resistive construction. The goal: a fire should not take out the pump feeding the sprinklers fighting that same fire. Overcurrent protection is very limited, sized to allow locked rotor current and long-term running. Fire pumps are one of the few motors intentionally allowed to run into damage if that's what it takes. Transfer switches must be listed for fire pump service. Transfer only the fire pump and be supervised. You cannot share an ATS with other emergency loads, use load shedding logic, or delay transfer unnecessarily. NEC versus CEC. Key differences. The NEC is extremely prescriptive, while the CEC is more principle-based. The NEC has Article 695, while the CEC has Rule 32200. The NEC's routing language is very explicit, while the CEC's is more about being protected and as reliable as practicable. The CEC relies more on AHJ judgment. Common field mistakes I see all the time. Fire pump fed from emergency panel included in load shedding, feeder routed through a parking garage without protection, shared ATS with life safety loads, and ground fault protection left enabled. High-rise reality check. In real high-rise projects, AHJs usually expect normal utility plus generator, a dedicated fire pump ATS, fire-rated routing, and clearly labeled equipment, with fire pump power taken ahead of everything else. If you want, next we can walk through a typical high-rise fire pump one-line, compare jockey pump versus fire pump power, go deep into generator sizing for fire pumps, or analyze inspection checklist items AHJs actually fail. Just tell me where you want to zoom in.